In this tutorial I will show how you can use the onboard or the built-in temperature sensor on the Raspberry Pi Pico hardware. So basically in this tutorial you will use the Raspberry Pi Pico hardware, and then you will use the built-in or the onboard temperature sensor on the Raspberry Pi device. We will use MicroPython as our programming environment, and we will also use the Thonny Python Editor. First, a short introduction to Raspberry Pi Pico. So Raspberry Pi Pico is a small microcontroller board developed by the Raspberry Pi Foundation. And Raspberry Pi Pico is a downscale version of the original Raspberry Pi, but since Raspberry Pi Pico is defined as a microcontroller, while Raspberry Pi is more like a small-scale computer, it's easier to compare the Raspberry Pi Pico with the Arduino environment. And as Arduino, but also the original Raspberry Pi, and the Raspberry Pi Pico is typically used for electronics projects, Internet of Things applications, etc. And typically you will use MicroPython, which is a downscale version of Python that is working on small microcontrollers like Raspberry Pi Pico. So then let's start with an overview of this built-in or onboard temperature sensor that is available on the Raspberry Pi Pico. So as mentioned, this Raspberry Pi Pico has a built-in temperature sensor, and the temperature sensor is inside the RP2040 microcontroller chip, which is located on the Raspberry Pi Pico. And this temperature sensor can be used for simple or basic applications and for test and demo purposes. So here you see the Raspberry Pi Pico hardware, and this is the microcontroller, this RP2040, and inside here this is this temperature sensor located. The information provided here is from the datasheet of this RP2040 microcontroller chip, and especially in chapter 495 you find detailed information about this temperature sensor. But basically the information that you need, it uses an internal ADC channel 4, and to convert from voltage to the temperature in degrees Celsius you need to use this formula. So basically the first thing we need to do is to use this read underscore U16 function that is part of microfunction in order to read a raw ADC value from the sensor. And this function gives a value between 0 and 65,535, and later this value has to be converted to a voltage between 0 and 3.3 voltage, and finally it has to be converted to a temperature value in degrees Celsius according to this formula. So basically this is the main code structure in order to read data from this internal temperature sensor. First, in initialization, as mentioned, you need to use this internal ADC pin number 4, and then you need to use the machine library and the ADC class in order to initialize this internal sensor. Then you need to read the raw ADC value using this read underscore U16 function in the MicroPython library. Then this raw ADC value, which is between 0 and 65,535, needs to be converted to a voltage value between 0 and 3.3 voltage, which is the reference value on the Raspberry Pi Pico, according to this formula as mentioned here. Then finally we need to convert the voltage calculated here to a temperature in degrees Celsius according to this formula, which is this formula that you find in the datasheet. So basically this is the main code structure in order to read the temperature value from this sensor. So now I have opened my Thonny Python Editor, and I have my MicroPython installed on the Raspberry Pi Pico, and the Raspberry Pi Pico is connected to my computer on COM8 in my case. So now I'm ready to start creating the application for reading the temperature value from this onboard temperature sensor. So then let's start by importing this machine library, which we need to use in order to use the pins and different parts of the Raspberry Pi Pico hardware. So then we need to initialize this internal ADC pin, which was pin number 4, which was used for this internal temperature sensor. And then we just create an object called sensor equals to machine dot ADC, which is the class, one of the classes in the machine library that we need to use in order to get data from the ADC chip that is part of the Raspberry Pi Pico. And then I just set the ADC pin we are using, which is 4, like this. Then we can start by creating a function to read this temperature value. So I call it just read temperature, like this. So this is a function. So then first we need to read this raw ADC value. So I just call it ADC value equals, and then we need use this define this sensor object that we need to use, like this. And then we need to use this read U16 function in order to read the raw value from the ADC chip, like this. So now we have read the raw value, which is between 0 and 65,535. Now we need to convert it to a voltage signal between 0 and 3.3 voltage. So then I just create a new variable called volt or voltage. And then we need to use this formula for converting from the raw value to a voltage value between 0 and 3.3. So then typically you do it like this: 65,535, and then multiply with this ADC value we have here, like this. And then finally we need to convert it to a temperature value, and that temperature value is in degrees Celsius. And then we use the formula that we found in the datasheet, which was 27 minus the voltage value minus this factor 0.706, and this should divided by another factor 0.001721. So this is the formula from the datasheet. So basically that's the function for reading the temperature value, and then you can use return in order to return the temperature value, return temperature, like this. So basically this is the function, and then we need to make our main program. Then we just use an ordinary while true, like this, an eternal program that runs forever until we click the stop button. And then we need to get the temperature value from this function we created, like this. So now, we use this function we created here, and then this function returns the temperature value that are put into this variable. Then we can print this value to the screen, print, like this. And then finally we can, since this inside the while loop we typically need to use a sleep function, then we can also import the time Python library, and then we can just use time.sleep which is a function inside this time library, like this. And then we specify in seconds. So let's say we want to read a value from the temperature sensor every 5 seconds. So basically this is the application. So let's just run it. And then you see we're getting a temperature value here. And this is the value from the built-in or the onboard temperature sensor that are located on the microcontroller on the Raspberry Pi Pico hardware. So then I can just stop the program. You see we get a lots of decimals here. Typically this sensor hasn't that accuracy, so we can use the round function, which is part of the MicroPython round, and then set that we should use 1 decimal only, like this. And then let's just run it, and then you see I get the temperature value with 1 decimal. So now it's 21.9, 22.4 degrees Celsius. So basically this is how we read and get the temperature value from the built-in or the onboard temperature sensor on the Raspberry Pi Pico. So now we have created a simple basic MicroPython program that are reading values from the built-in temperature sensor. You can also improve the code by creating a separate Python class and a separate Python module. So let's do that. So then I start by just copying this code into a new empty script here, and then I do some modifications. So now this will be the new Python module and the Python class that we are going to use in our main program. So then I just do some improvements from machine import ADC. By doing this, we only import the ADC class from the machine library in order to save some space, because now I'm going to save this file on the Raspberry Pi hardware. So since the Raspberry Pi Pico has limited resources, I choose to do it like this. Then we will create this class. So then I just use class. I create a class called temperature, like this. And then this will be the main function of this temperature class. And then we need to create a constructor. So then we just use def init. So this is the syntax for creating a constructor in Python. And then we use this part inside the constructor, like this. And since now we have imported only this one, we can remove this one. And then use this self, because we use this self for internal variables inside the class, like this. So now we have basically created the class called temperature, and it has this main function that are reading the temperature, and it has this constructor. And then we can save this file to the Raspberry Pi Pico. Select Raspberry Pi Pico, and then specify a file name. Then I call it just Pico sensor.py or something. Click OK. And then, so this is the Python library or module that we are going to use. And now I'm going to create the main application, which will be very simple then. The first thing we need to do is to import from this new library called Pico sensor. So import Pico sensor, from Pico sensor import and I will import this class temperature like this. And now I can just do like this, define an object or a variable of this sensor equals to temperature like this. So this is basically the constructor which we find here. So now we have defined an object of this sensor using the constructor inside this temperature class. Now we just use this the main program using a while true function like this, and then you just read the temperature value. Temperature equals to then sensor dot a name of the function, which is read temperature. Like this. And then we can print the temperature value like this, and then finally we can use this sleep function. So then we need to import time, and then time dot sleep, and then we use the same 5 seconds like this. So basically this will be now our new main program compared to this previous. This was our previous program where we had everything into one program. Now we have split it into a new, by creating a new Python class and a Python module with the name Pico sensor, which is now located on the Raspberry Pi Pico. And I can go to files here, and then you see this Pico sensor.py is now located on the Raspberry Pi hardware. While this one is files that I have on my personal computer, this is files that are located on the Raspberry Pi hardware. So now we have this Pico sensor, which is here, and then we have the main program here. Then I can just name it also. I can also save this one to the Raspberry Pi Pico hardware. You can just call read temp example or something. You can call this one whatever you like, and it has to have this .py extension. So now we have 2 files on the Raspberry Pi Pico hardware, the Pico sensor, which is this main module and the main class that we are going to use, and here is the main application where we're actually using this Python module. And because we do this because this is a better way to structure our code, and it's much easier to reuse the code from this library into other applications. So now we could have created different applications that are reading values from this temperature sensor by just using this Python library that we have created. So let's see if it works. So let's just run it. We get some error. There are some minor updates we need to do in this Pico sensor class. So basically, the input to the read temperature function need to be this self, and then instead of using this sensor, we also need to add the self here, because this now will be an internal variable of this class. So then self need to be an input here, and then self.sensor, which we have here, dot read u16, which is the function for reading the raw ADC value from the Pico hardware. So now hopefully when I save this one, and then let's run the main application once more, and hopefully now it will work. And then you see we are able to read a new temperature value from the Pico hardware every 5 seconds. So basically this is the same application as this was the application we started with, where we put everything into one file or one script, but by splitting into 2 files, then this first file is the Python library with a separate class, and then we name it picosensor.py, and then we can use that library and that class here in our main program, and this makes the main program easier to read and easier to maintain, and it has fewer code lines compared to this previous example, and it makes it easier to reuse this code in other applications or in other scripts. So basically this is some examples how you can create code for reading values from the built-in temperature sensor on the Raspberry Pi Pico hardware. So that's all. So good luck with Raspberry Pi and Raspberry Pi Pico and MicroPython, and using the built-in sensors in different applications. Thank you and goodbye.